Okay, I'm going to work out about 4 examples of explaining how to solve quadratic equations by completing the square. So these are the steps, so you can pause it and look at the steps, but I'm just going to run through the steps using examples. Okay, first example. You normally want to move the constant over to the right, but you can see that the constant is already moved to the right. So the next thing to do is to get it ready to add that special c that makes the left-hand side a perfect square trinomial. So remember to figure out the number that goes in the blank. It's going to be half this number here squared. So half of 4 is 2, and 2 squared is 4. So that's the number that goes in the blank. And of course you have to put it on both sides of the equation to keep your equation in perfect balance. Now when you do that, on the left hand side, this side becomes a perfect square trinomial, and it always factors really nicely. It's always x plus whatever the square root of that is, or x minus depending on the sign of this number. So this one is x plus 2 squared equals, on the right hand side you just add those numbers together, so that's 16. Okay, the next step is to take the square root of both sides, so we take the square root and that undoes the squared, so you're just left with x plus 2 equals, and then on the right hand side you gotta take the square root as well, so plus and minus 4. Then we're going to still try to get the x by itself, so we have to subtract 2 from each side. So that cancels out. So x equals, and I usually put this number in front, so it'd be negative 2 plus and minus 4. And so we have negative 2 plus 4, which is a positive 2. And we have negative 2 minus 4, which is negative 6. So these are the two answers, 2 and negative 6. And sometimes you'll see them in set notation like this, 2 comma negative 6, or you could just say x equals each of those separately. Okay, next example. We're going to move the constant over to the right hand side. So I'm going to leave a blank. And I have negative 24 is what that would be if I added it over or subtracted it. So minus 24 from each side. I'm going to think of the magic number that I should put here to make the left side a perfect square trinomial. So half of 14 is 7. 7 squared, 49. So we add 49 to each side. That creates a perfect square trinomial on the left, so this will factor nicely. It'll be x minus whatever the square root of 49 is, which is 7, and that's squared. And negative 24 plus 49 is 25, and then I'm going to take the square root of both sides. So that undoes the squared, so that leaves you with x minus 7, and on the right that's plus and minus 5. And then the last step is, well, close to the last step, is to get rid of the minus 7 by adding it. So x equals a positive 7 plus and minus 5. So we have two answers out of this, 7 plus 5, which is 12, and we have 7 minus 5, which is 2. So we have two different answers there, 12 and 2. Oops, I think I pressed the wrong thing there. Okay. So next problem, I'm going to move that negative 5 over, so moving the constant over. So, and I'm going to leave a blank. So that's 5 plus a blank. So the magic number here is half of 2, which is 1. 1 squared is 1, so we're going to add 1 to each side. The left side will factor really nicely, so it'll be x minus 1 quantity squared equals a positive 6. Then we're going to take the square root of both sides, so square root, that will leave us with x minus 1, and then on the right hand side that's plus and minus the square root of 6, and then the last step is to get the 1 over to the other side, so it's a minus 1 right now, so we're going to add it over, so that's 1 plus and minus square root of 6. So those are the two answers. 1 plus radical 6 we call it, or square root of 6, same thing. 1 minus square root of 6, or 1 minus radical 6. Okay? And another one here. So I'm going to move the constant over. So you could pause it, and try the problem before I do it. So half of 6 is 3 squared, so 9 is the magic number there. Then I'm going to factor the left-hand side, so that would be x plus 3 quantity squared equals 11. And you can tell that this one's not a perfect square either. No big deal. So we take the square root of both sides. X plus 3 equals plus and minus the square root of 11. And we have to get the x by itself, so we're going to subtract 3. So that would be negative 3 plus and minus square root of 11. So those would be the answers. There's one other thing that comes up every once in a while when you're solving these equations, and that is sometimes the left-hand side is already a perfect square. So if you look at this, you can just look at it and say, okay, well, you can already factor this as a perfect square trinomial. You can see it's 4 is a perfect square. So I can go right to x minus 2 quantity squared equals 16. So that's, instead of moving the constant over to the right, you can just look at the left-hand side and see if it's already ready to go. In other words, there's kind of like already this c that's been added, if you want to think of it that way, but it's already a perfect square. So then you just proceed and you take the square root of both sides, so that leaves you with x minus 2 on the left, and then plus and minus the square root of 4, and then we're going to add that 2 over, so 2 plus and minus 4, and you can see we get two answers out of this, 2 plus 4, which would be 6, and 2 minus 4, which would be negative 2. So you can put that in set notation or however you like. So I think that'll do it for us on completing the square.